Hello, Precalculus students. This is Mrs. Laker. I am here to take you through your day 2 notes. We're going to talk about graphing those rational functions, which we talked about the nuts and bolts from day 1. At this point in time, if you did want to pause, some of the key from the warm up is showing right now, but if you wanted to pause and try the warm up first and then replay the video to check your answers, you can. This is a good time to do that. Okay, if you have unpaused, it means that you want to check out the answers to the warm up. So here we are. Um, what you found is if you were trying this warm up and you got to part D and E, you did need to be reminded of that the sum and the difference of cubes, when you factor them out, I wrote this out in purple up here. As a reminder, here is the format when you factor those out. From that was back from Algebra 2, so it's been a minute since you've seen it. So if you needed a reminder, there it is. But we'll start with part A. So a reminder from last time we looked at, when this is in standard form like this, we looked at, okay, the leading coefficients are tied, which means that your horizontal asymptote is going to be the leading coefficient over the leading coefficient. So that's going to be y is equal to 3/2. For your vertical asymptote, you always look into the denominator and just set the denominator equal to 0 and solve for x, and that will give you your x value for which the denominator will be 0. So that turns out to be -3/2 as well. Let's see. For the domain will be affected by the vertical asymptote. So that's why the domain looks from -infinity to -3/2, union -3/2 to infinity. And then for part B, you see here the leading degree is top heavy by 1. So that means you're going to get a slant asymptote or oblique asymptote. So you are going to need to do long division. So after you do long division, I showed my work off here to the side. You should get y is equal to 2x minus 2. And the vertical asymptote, of course, from the denominator is going to be -1. And remember, the vertical asymptote is the only asymptote that will affect the domain. The slant asymptote does not affect the domain. And then for part C, we are bottom heavy here, which means the leading degree is more in the denominator than in the numerator. So therefore, this is a proper horizontal asymptote at y is equal to 0. No work involved. And then your vertical asymptote, of course, after you set the denominator equal to 0, is -1/3. And of course, that affects your domain. And then once you get to part D, you do have to fully factor out the denominator. So that is the difference of cubes. And like I reminded you in the purple at the top of this page, if you need to, you can stop and rewind. You can see that fully factored out. And the quadratic trinomial to the right here, that one is not factorable anymore. So that means you have to use quadratic formula, which you can see my work here. And then you end up getting an imaginary number. So therefore, the only vertical asymptote is actually x is equal to 2. Okay, and then we get to part E. Now this one has a sum of cubes in the denominator, so you need to fully factor and expand this out. So that's why I rewrote the rational function the way I rewrote it, fully expanded. And then what you can see is that when you try to do the quadratic formula again for that quadratic trinomial, it ends up getting you an imaginary number again. So the vertical asymptote is only going to be -3. And because your leading degrees are tied at x to the third power, you're going to get a horizontal asymptote at y is equal to 8/5, because those are the ratio of the leading coefficients. Okay, if you need to pause or rewind the video to see the warm-up, go ahead and pause and rewind. Otherwise, if you're ready to take some notes, go ahead and grab the packet that you received from the sub, and then we'll start with looking at the first page together. Okay. So the first page of the packet, you can see all the steps written out for graphing rational functions, and there's just a lot. There's a lot to look at. There's a lot of details. We did look at a lot of the nuts and bolts from last time I saw you guys, but we're going to look at a few new things today as well. So that comes with the highlighted part, like part 3C. We are going to talk about holes today and learn how to graph them. And we also, we talked about horizontal and slant asymptotes in step 5, but we did not talk about if the graph can cross the asymptote or not, or when that actually happens. So we'll see that happen today. And then we'll also talk about, okay, well, we've run out of like y-intercepts or x-intercepts or any other points. And what if we need more points to be able to graph or to find out where the graph is? Okay, so we'll talk about that as well. And then, of course, we'll graph it. So if you're ready, go ahead and flip the page and we'll do example 1 together. Okay, I've got to turn around my computer here. Hold on. Here we go. Okay. So here we go. Okay, so we're going to first fully factor out example 1 so that I have both it in standard form and also in factored form so that I can write down everything that I need. So here we go. Let's factor this out. This will be x squared over x plus 3 times x minus 2. Make sure I factored that correctly. That looks good. Okay, so now I can start with my important bits of information. So I have my vertical asymptote that I will start with. Okay, and then I'll put the x values of anything that makes that denominator 0. So it looks like I'm going to get negative 3. X is equal to negative 3. There we are. And x is equal to 2. And then we'll look at a horizontal asymptote. Let's see here, I can see my leading degrees are tied. So therefore, we're going to have a horizontal asymptote as y is equal to the leading coefficient over the leading coefficient. So that will be y is actually equal to 1 because 1 divided by 1 is, of course, 1. Okay, so that means, of course, there's no slant asymptote. Okay, then we'll move on to the x-intercepts. Okay, so we'll see if there's any x-intercept or intercepts. There could be more than one. So let's take a look. So when we're solving for the x-intercept, we got to plug in 0 for y. So that would look like this. If you're showing your work off to the side, it would be 0 is equal to x squared, of course, over x squared plus x minus 6. However, that denominator, when you multiply that denominator on both sides, it zeroes out. So really what you're doing is you're setting 0 equal to x squared, 0 is equal to the numerator. So you always, whenever you're trying to solve for x-intercepts, you just set the numerator of the rational function equal to 0. And when you solve, you should get x is equal to 0. So that means your x-intercept is, of course, at 0, 0. For the y-intercept, most people could already guess where this is going because of what the x-intercept is, but let's show the work anyway. So when we want to solve for the y-intercept, we want to plug in 0 for x. So that would look like this. I'm showing my work off to the side here. So we'll get 0 squared over 0 squared plus 0 minus 6. So this will be 0 divided by negative 6, which is just 0. And of course that makes sense because the x-intercept was 0, 0 anyway. Okay, so we have everything we need at the moment. And this is everything that we talked about from day 1. So we'll start graphing here, and I'll show you a little bit more as well as we go. So let's graph those vertical asymptotes first. We're at negative 3. Okay, and then at 2. Okay, and then the horizontal asymptote is at y is equal to 1. All right, so I have all my asymptotes graphed. I also want to graph my points, which unfortunately I only have 1 point. So I only have 1 point, which is the x and the y-intercept. Okay, so we need to fully graph this rational function. So if you look here at our 1 point that we have, it can either go up, right? We can either put the polynomial up or it can go down. Now, because there's a horizontal asymptote at y is equal to 1 right above the point, most likely this graph should go down and it should follow these asymptotes here. Okay, well, I'll show you how to check to see if the graph crosses the horizontal asymptote in a few minutes. But for right now, that's logically most likely the way that it's going to go. And the way you can, of course, make sure is that we can also plug in other points, to the left and right, like maybe -1 or 1 to quickly find out other points if you were still unsure. But because I know that it's going to go down because of that horizontal asymptote up there, and because I know I'm going to check to see if it crosses the horizontal asymptote later, I think it's pretty safe that we can say that this is going to point down. Okay, but that being said, I still need to check to see some other points because I need to know where the graph is to the left of my vertical asymptote at x is equal to -3. So I have 2 asymptotes. I'm making a number line here in blue here. I have asymptotes at -3 and 2. And I really need to figure out where the graphs are. So to the left of -3 it would be nice if I plugged in maybe -4 into my graph and then found out what the y value was. So I know, is it above the horizontal asymptote or below? Now, because I have no other x-intercepts, most likely the graph would be above the y is equal to 1 horizontal asymptote directly to the left of -3. Because of course you have to have an x-intercept to cross the x-axis. But just to show you the work and to show you, to be thorough and everything like that, you would plug in -4 into your graph. So this into your equation. So it would be -4 squared over -4 squared plus -4 minus 6. Okay. So where are we going to get 16 over, and then this would be 16 minus 4. So it's 12 minus 6, 16 over 6, it looks like. So 16 divided by 6. I'm doing this in my calculator with you as well. So that becomes 8/3, which is about 2.66. So 2.67 approximately. Okay, so that's a point. So we're at -4, 2.67. So 2.67, so about there. Okay, so that means, like I thought, the graph is above the horizontal asymptote directly to the left of the vertical asymptote at x is equal to -3. Okay, so that part of the graph is filled out. Now, of course, the graph cannot exist right below the graph that I just drew in, otherwise it wouldn't pass the vertical line test. So I know I'm done with that part of the graph. So the only other part of the graph that I'm not sure where it is would be to the right of 2. And for the same argument we made for to the left of -3, since there's no other x-intercepts, most likely it's above y is equal to 1 because, of course, we don't have another x-intercept. But again, to be totally thorough, we can plug in a point like 3. That's directly to the right to see where this goes. So f of 3 is equal to, and then I would have 3 squared over 3 squared plus 3 minus 6. So this would be 9 over 12 minus 6, which is 6. Looks like 3 halves, which is 1.5. Okay, so it looks like it's at 1.5. So this point would be at 3, 1.5, which is here, which again confirms what I had thought. The graph is above the horizontal asymptote. And that's all you would need to show. You just need a few critical points just to show where the curve is, because we already know that it's going to hug the asymptotes. Okay, the last thing I need to show you, and this is something that's new. So the graphing part was new today, but everything else we really knew how to find. This is completely new. I have to check if it crosses the horizontal or slant asymptote, because we have a horizontal asymptote. We have to check if it crosses it. So off to the side here, we're going to say check for crossing horizontal asymptote. Okay, so that's what we got to do. To do that, you take whatever the horizontal asymptote is, and I'm going to highlight this in blue. The horizontal asymptote, it says, is y is equal to 1. So that means when I'm checking for crossing to see if it crosses, you plug in 1 for y equals your x squared over x squared plus 6 minus 6, or plus x minus 6. I use standard form because it's a little easier for me than to solve for x. You could use it in factored form, but you just have to refoil. Okay, so again, where this 1 came from? It came from, that is your horizontal asymptote. Okay, so my goal is here is to solve for x. Now, if I solve for x and I actually get an x value, that's the point where it crosses the horizontal asymptote. But if I do this and I try to solve for x and I get an undefined answer, like for example, like 2 is equal to 6, well, then it doesn't. Then it's undefined. It does not cross the horizontal asymptote. Okay, so simply I am solving for x. So I'm going to throw this guy over 1, just cross multiply. So I'm going to get x squared plus x minus 6 is equal to x squared. So x squares will cross out. X is equal to 6. It does cross. Okay, so because I got actual value, it crosses the horizontal asymptote at 6, 1. Why, 1? Because that's the horizontal asymptote. Okay, so I'm going to redo my graph here. Okay, so 6, 1, that's about like right there. Okay, so I'm going to erase that just so I can show you where it crosses. So it crosses at 6, 1. So it crosses right there. So I marked it so I know where it's crossing the horizontal asymptote. So here we are. And what's going to happen is it's going to come here through that point that we already had at that blue point. And it's going to cross the horizontal asymptote, dip down here, but then it's going to come back and it's going to hug the horizontal asymptote again. And again, it won't cross the x-axis because I don't have another x-intercept. It can't do that, but it will just cross the horizontal asymptote and then hug it again. And that's what it looks like. Okay. That completes example 1, part A. Now, if you have any questions, you can pause and rewind. Otherwise, if you are ready, we can go on to part B. Okay. Here we go, part B. Now, part B I want to do with you because for this one, as you can already tell from the standard form that it's in, the leading degree in the numerator is bigger by 1 than the leading degree in the denominator. So if you're thinking, oh, hey, that's going to be a slant asymptote, you are correct. Okay, so let's factor this out the way we normally do. So let's go here and factor this out. F of x is equal to, and let's go, what is this, x minus 4 times x plus 3 over x plus 5. Should be factored right. Okay. All right, and then we'll start with what we normally start with. We always start with our vertical asymptote here, and then that should be at x is equal to -5. Okay. And then we're going to have a slant asymptote. We're not going to have a horizontal one. We're going to have a slant, and we got to show some work for this. So let's go off to the side here. Okay, and then here we go. Okay, so off to the side here, and we are going to do some long division. So here we go. We got x plus 5 and then divided by this x squared minus x minus 12. Okay, we'll do some long division, figure out what the slant asymptote is. So where I'm going to pick x times x, put my minus sign in here, is x squared. X times 5 is plus 5x. Okay, and we're going to subtract down 0. And then this becomes negative 6x minus 12. Carry that down. Okay, and then minus 6, because minus 6 times x is negative 6x. Then negative 6 times 5 is negative 30. Okay, this should zero out the way it should. And then that looks like it should be 18. And that's the remainder. Okay, but we always graph just the quotient part up here, not the remainder. So we're going to get y is equal to x minus 6. That's the slant asymptote. Okay. So again, if you need a reminder on long division, you can rewind that or pause it. Otherwise, I'm going to keep going with our important bits of information. The x-intercepts, I'm going to look at my numerator and set it equal to 0. Okay, so for the x-intercepts here, I'm going to take this x minus 4 times x plus 3 and set it equal to 0. And so I'm going to get 4 comma 3 and 4 comma 0 and negative 3 comma 0. So your coordinates, and this is a little squished, I apologize about this, but your coordinates should be 4 comma 0 and negative 3 comma 0. And I'm just going to write a reminder here is that we set the numerator equal to 0 and you solve for x. Okay. The y-intercept. The y-intercept, I like to look for the y-intercept when it's in standard form. And you look at the constants, really. So if you plug in 0 for all your x's, you're left with negative 12 fifths. So 0, comma, negative 12 fifths. And let's see, negative 12 fifths is like, as a decimal, it is about negative 2.4. So that we know how to graph. Okay. Okay, so we have everything we need at the moment. So we are going to graph our asymptotes first. So let's graph those. We're at negative 5. Okay. There's only one vertical asymptote, and then we're also going to graph our slant asymptotes. And we're going to start at negative 6, up 1 over 1, just like what we did in Algebra 1. Okay, and then keeps going this way. Goes like that. Okay, we've graphed our asymptotes. And let's graph our coordinates. It looks like we have a lot of them. That's nice. So we have our x-intercepts at 4, 0, negative 3, 0, and 0, negative 2.4. And so I can graph this. I'm going to follow the asymptotes. And it's going to look something like that. Okay, I didn't need any other points to find to be able to graph that one. But I do have to figure out, of course, on the left side of the vertical asymptote x is equal to negative 5, is it above the slant asymptote or is it below? Now, we don't have another x-intercept anywhere, so chances are it should be below the slant asymptote, but I'm going to show you just how to confirm that. So over here, if you make your number line, quick number line, negative 5 is here. I need to know if it's, above or below that slant asymptote on the left side. So I'm going to test a point. And why don't we just test negative 6? So we're going to go f of negative 6 equals, and then we're going to go negative 6 squared minus negative 6 minus 12 all over negative 6 plus 5. And we type that into our calculator. So we should get, what is that, 36 plus 6 minus 12 divided by negative 1. So I'm getting negative 30. Okay, should be negative 30. And that does make sense because, like we thought, it should be below because we have no other x-intercepts here. So my graph is at negative 6, negative 30, which is way down below. It's off the graph. But to be able to graph it, I'll show you what it looks like. It looks like this, following those asymptotes. It kind of goes into my notes there. Sorry. But that's how the graph looks like. And now this graph is complete. Just like we do check to see if the graph crosses the horizontal asymptote, we do have to check to see if it crosses the slant asymptote as well. So to do this, you actually just set the slant asymptote equal to the rational function. So we have to do that as well, just to make sure. So over here, sorry guys, there's a lot of work involved here, but we got to have a little more space. So check for crossing the slant asymptote. Okay, so we're going to take the slant asymptote, which is x minus 6, and set it equal to this x squared minus x minus 12 over x plus 5. And of course, we're going to multiply by x plus 5 on both sides, and we're going to FOIL that. So then we'll have x squared. What would that be? Minus x. 6 times 5 is negative 30 is equal to x squared minus x minus 12. The x squareds will cross out. The negative x's will cross out. And then what you get is you get negative 30 is equal to negative 12. And that's not right. That doesn't make sense. That's invalid. So therefore, when that happens, then we know that it doesn't cross the slant asymptote. So we're good. We don't have to change our graph at all like what we did in part A. Okay, and then we pause, and then if you need to rewind or see this problem again, go ahead and do that. Otherwise, if you're ready for part C, I'm going to show you what a graph looks like with a hole, because that's the last thing we haven't talked about yet. Okay, so we're going to do part C together, and this will be our last example together, and then I can have you guys try part D and part E. Okay, so we're going to start the way we normally start, and we're going to fully factor this guy out. So we're going to get f of x is equal to, okay, we're going to factor this. So 2x minus 3, and that would be 3x plus 1, 2x minus 3, x plus 2, I think. Just make sure that's fully factored right. That would be... should be minus 2, shouldn't it? There we are. Okay, that's negative 4x minus... Okay, so that looks factored correctly now. Okay, so now we're going to go through our important information. Oops, there we are. Okay, so first of all, you should be looking when you see this fully factored and you should want to do something, and it's because these guys cross out. Okay, when that happens, that's when a hole happens. Okay, so we have a hole. So let's say hole, and it's going to be at, now to figure out the x coordinate of the hole, you just set that 2x minus 3 equal to 0, which would be 3/2. Okay, so it's whatever makes the quantity of the whole 0. So it'd be 3/2. Now to figure out the y coordinate, we got to do a little bit of work. So we have to put in and substitute in 3/2 for x of what's left of the function after you take out the whole, after you cross out the whole part. So to do this work, you'll put f of 3/2 into 3 times 3/2 plus 1 all over 3/2 minus 2. Okay, so this should be, I think it's 11 or negative 11, but I'll double check with my calculator. So this will be 3 times 1.5 plus 1. Yep, negative 11. Okay, so this is negative 11. So you type that into your calculator, you should get negative 11. So at that point, there's a hole in the graph. Of course, I will show you how to graph that one, but just so you know what it is at the moment. Okay, then we move on to all the other information. So vertical asymptote is going to be at x is equal to 2. Now, a vertical asymptote cannot be a hole. Even though that 2x minus 3 is in the denominator, that's a hole. It cannot be also a vertical asymptote. So it's one or the other. Let's see. We had, the degrees were tied. So that means that you have a horizontal asymptote at y is equal to 3, because 6 divided by 2 is 3. So of course no slant asymptote. And then we have x-intercepts. And the only x-intercept I think I have at the moment is this negative 1/3 comma 0. Okay. And of course, again, x-intercepts cannot be holes. Okay, so once you cross out that hole, it's a hole. Okay, and then that leaves the y-intercept. Okay, let's see. The y-intercept, we're going to plug in 0 for x. And once you do that, now when you're plugging in 0 for x, you plug it in, of course, for what's left of the function after you cross out the hole. So really what it should be looking like is it should look like 3 times 0 plus 1 over 0 minus 2, which would be negative 1/2. So 0, negative 1/2. Okay. Now we have everything we need and we'll start graphing. Okay, so we have, let's take a look. Vertical asymptote as x is equal to 2. Okay. Horizontal asymptote at y is equal to 3. Okay. And we'll graph our points. So we have at negative 1/3 comma 0. 0, those points are very close together. And the hole, let's graph that as well. That was at 1.5, negative 11, slightly off the graph here. And then when you graph the hole, just make an open circle. That's what it looks like. So I can connect all these. Connect, it will go really close to the asymptote, go through here, go through the open hole. Okay. And there we go. So there's half the graph right there. Of course, we have no other critical points. So if we do a quick number line, of course, we put our, this is going to be 2. Our vertical asymptote at 2 would be nice to know if the graph was above or below the horizontal asymptote on the right there. Of course, I'm thinking it's above because we have no other x-intercept. So good chances are it's above. But if you want to be thorough and plug in like a positive 3 to really see where it is, you'd plug in 3 to what's left of the graph there. So it'd be like 3 times 3 plus 1 over 3 minus 2, and that looks like it's 10. So 3 comma 10, 3, and then up 10. So it would be up here, this point. So of course that means that the graph is above the horizontal asymptote to the right of the x is equal to 2 asymptote, which makes sense because we had no more x-intercepts. So that makes sense there. And then the last thing to do is just make sure that the graph didn't actually cross the horizontal asymptote anywhere. So we'll just do a check really quick. Check for the horizontal asymptote crossing. Last one that we'll do on this page here. Okay, so let's just quickly check. We'll put 3 is equal to, we'll put this 3x plus 1 over x minus 2. And then we'll multiply by x minus 2 on both sides. So this will be 3x minus 6 is equal to 3x plus 1. 3x's will cross out. Negative 6 is not equal to 1. So therefore, it does not cross the horizontal asymptote. No need to change the graph at all. So there we have it. That is part C. If you need to see this example again, you can go ahead and replay it. Otherwise, I'd like you to try part D and E, and I will post the filled out key for you so you can check that on Classroom as well. But maybe give a few a try because this was a lot that we did together. Okay, thanks everyone.